Bismillahirrahmanirrahim. Today the topic is about the design of doubly reinforced beam. The question is design a rectangular beam for moment dead moment, that is 3 to 5 feet into cube, and ml moment life is 400 feet into cube. FC prime is 4000 psi and Fy is equal to 60,000 psi. The maximum permissible beam dimension are that dimension are fixed. The depth of the beam is 31 inch, breadth is 15 inch, D dash is 3 inch, and D is 25 inches. So the solution: MU moment, ultimate moment. So changing that to that service load to moment load, 1.2 with dead load and 1.6 with live load. So we will multiply this 1.2 into 325, which is the dead load, plus 1.6 into 400. This which will give us the 1030 feet into cubes. Now solution: step number 1, starting design. Assume A is 2 multiply H. H is how 31 inch, so we will get 6.2. The area of steel formula is mu divided by phi Fy into D minus A by 2. Putting the values of all these which are available, we have 30 into 10 into 30 feet cubes. Change multiplying this 12 to change that feet into inches. So we will get that AS is equal to 9.19 inches square. Now doing the trials, we will again put this AS into A to get the A values, whether which value we select are good, are right or not. So the formula is ASFY divided by 0.85 FC prime into B. Putting all the values and doing the calculation, we have AS 9.19, this Fy is 60, a 0.85, FC prime 4, B is 15, gets the value of A, which is 10.81. Doing the second trial, which is also same to the first one. The second trial is AS into MU, same formula. Putting the values here, the value of A will be changed. We will put this value because this is a trial of design. 10.81 divided by 2, we get the AS area of steel value, which is 10.12. Now A, putting again this AS into A, we get the A value, which is 11.9. Going further to the third trial, same formula for the AS, which is this one, and for A, putting the values here, we will put the A value which we find from the second trial. Now we get the area of steel 10.3, and again putting this area of steel into A, we put the A value 2.1. Now looking at our values, whether it is coming close or not. Look at A, it come close, and also area of steel come close, so it means that we will select the area from this second and third trial. So after the trial, AS comes out to be the 10.3, so area of steel is 10.3. Now area of steel maximum singly, because this is a doubly reinforced beam, there the tension zone, there will also be a steel provided and also in compression zone. So this area of steel maximum singly formula is 0.27 FC prime divided by Fy into BD. This formula is for grade 60. Clear? So now A is maximum singly 0.27 into 4 divided by 60, 15. Putting just the values, B is 15 and the effective depth is 28. We get that area of steel maximum singly is 7.56. Now checking, the area of steel is greater than area of steel maximum singly, which is 7.56. then we will design a doubly reinforced beam, because this is the requirement that must be less than from this area. If it comes greater from this, so it means that we will design a doubly reinforced beam. Now assuming a sorry now a is equal to a is maximum singly, here we will again find the area a, but here we will put that singly area of the steerer, and also same formula we put that, get that a is equal to 8.9. now find moment maximum singly, formula is phi as maximum singly fy into d minus a by 2. Just putting the values, if fi is equal to 0.90, a is maximum 7.56, fy is equal to 60, d 28, and a is 8.9 divided by 2. We get the moment of maximum moment singly, which is 96414 kips into inch. Now moving further to the step number 2, moment to be carried out by the compression steel. Now mu extra, just we will minus that mu maximum singly from the total moment. Here the total moment is 12,360, which is 1030 multiplied 12, we get this value minus this moment. We got mu extra 2746 inch into kips. It means that this moment will cause in the compression zone. Now steps number 3, just we will check that whether the compression steel yield or not. From ASI table 3, give that one from the design book. 31 inches our depth, it must greater than it must be greater than 21.5, so it is. So now, and for d dash is 3, d dash by d 3 by 31, which is 0.096, and the design value is, which the table give us, that is 0.12. So it is less than 0.12 for grade 6 steel, so it means that the compression steel will also yield. We will design for this as well. Calculation. Now step number 4, calculation as which the steel will come in compression zone, as dash, and ast the total. Now mu extra, as dash is equal to mu extra divided by the same formula. Here is phi fs prime is equal to fy, which is 60,000 psi, 60 ksi, d minus d dash. So putting the mu extra 0.9, 60, fs 60, and 31 minus 3. Doing the calculation, get the value of as prime is, there is 1.81 inch square. The total amount of steel tension reinforcement AST, so AST is as maximum plus AS dash. AST is equal to 7.56 plus 1.81. 7.5 is the area of steel maximum singly, and 1.81, that is area of steel which is used in compression zone. Both will be added, we get that AST is 9.37. For this we will design for this area we will design the beam. The steel area should not be less than from this which we will provide in the beam. Now using number 8 bars, area of one number 8 bar is 0.79, say 0.8 inch square. So number 8 number of bars to be provided on tension side. So number of bar tension side, AST, area of steel, which is 9.73 divided by area of bar 0.8. We will divide this on this, get that 11.71 bars, say 12 bars. Clear? Now number of bar to be provided on compression side, area of steel in compression side, AS prime divided by area of one bar, that is 0.26, say 3 bars. provide 12 number 8 bars on tension side and 3 number 8 bars on compression side. Now, step number 5, it is not that much important, but just ensuring that whether our depth that is okay or not. So this is just a check. Now step number 6, ductility requirement. AST, area of steel, should be less than or equal to area of steel maximum. Now AST, which is the total actual steel area provided, must be less than the AST maximum doubly. Clear? The area which is provided, it must be greater than the area which we find. Clear? If we provide the area less than which we find, means this area, sorry, from this area, so the design will be failed. Now AST maximum W, AST maximum plus AS dash FS by FY. If you are not interested in this, this is both 60 by 60 will 0. Now AST maximum will be 1, so AST maximum single plus AS dash, uh, that is 12 number of bars multiply 0.75 1 bar area plus 3 number of bars multiply 0.79 1 bar area. 12 is the number of bar used in tension side, 3 is the number of bar used in compression side. So AST maximum W is 11.85 inch square. Now come here, therefore AST is 10.3 and AST maximum W is 11.85. This is less than this one. This area is less than this one. It means that our design is okay. Step number 8, the last step, drafting, providing 12 number 8 bars in 3 layer in tension side and 3 number 8 bars in 1 layer in compression side. Now this is the diagram of the beam cross section. This is depth, that is width, that is d dash, effective depth, and number of bars to be provided in compression tension zone in 3 layers, and this is number of bars in compression zone. Hope you will get something from this. Thanks.